Hello guys, I'm Pranav Katta and I'm going to give the introduction for multiplier circuit for the lab 9. So here we have provided a 10 volt input in the circuit and the frequencies provided are 1 kilohertz with 1 volt peak to peak and 10 kilohertz with 2 volt peak to peak. The circuit diagram is as shown and the connections are made accordingly. Here as expected, this is the output waveform which we are getting, and this is the FFT. This is the output FFT which we got, and this is the calculations of the wave signals. 2 into sine of 2k pi t into sine of 20k pi t. On simplifying, we'll get cos of 18k pi t minus cos of 22k pi t, which from which we could infer that we should get two frequencies, which is 9 kilohertz and 11 kilohertz. We should get peaks in the FFT here. Let's verify. On the cursor, as we could see, it is at 8.75 and 11.2. The peaks are at 8.75 and 11.2, and thus it is verified.
Hello everyone, I am Pranil Joshi and I am going to explain you the question number 2 of the assignment. So for this question we are using the multiplication of two sinusoids, which is 1 VPP 5 kHz and 2 VPP 10 kHz. So the output is, so the multiplied signal is passed through a differentiator, which is a high pass filter. The high pass filter filters out the highest maximum frequency component present in the input. So as we are using 5 kHz and 10 kHz sine signal, so in the input there will be two sinusoids which will be comprising of 5 kHz and 15 kHz as explained in the first question. So now we are passing it through the differentiator circuit which we have made. The resistor which we are using is 3 kilo ohm and the capacitor is 10 nanofarad.
Hey, I am Prayas Kulkarni. So I'm going to give the reason why we have chosen resistance value as 3 kilo ohms. For a high pass circuit, we need to filter out the dominant frequencies. So for the cutoff frequency, we have chosen 5 kHz as our cutoff frequency. Then we have to find the value of resistance such that all the frequencies above it will the dominant frequency will be filtered out. So with the formula, such that resistance should be smaller than 1 by 2 pi f naught c. We are getting and the capacitance is 10 nanofarads. So resistance should be smaller than 1 by 2 pi into f 5 into 10 to the power 3 into 10 nanofarads. So which gives us value as resistance should be smaller than 3.18 kilo ohms. So for this we have chosen a value of resistance as 3 kilo ohms.
So after so the input is passing through this and the output is shown in the DSO. We can see that the frequency which is close to is almost equal to 15 kilohertz. It shows that the filtering is done properly, and this is the FFT. So this is the FFT of the input of the filtered signal. So we can see that the maximum peak is present here. So we'll now check which is that frequency component, and we see that it is exactly 15 kilohertz. So this shows that the filtering is done properly and we are getting the desired output. Top image is of the output of the multiplier circuit, which is the input of the differentiator circuit, and the below image is of the sinusoid which we obtain after passing it through the filter. The filter is high pass because it is a differentiator circuit. After passing through the differentiator circuit, the low frequency component gets attenuated and the high frequency component remains as it is. And as the low frequency component gets attenuated, we can see that the shape changes drastically, and the dominance is of the high frequency component.
FFT of our original multiplier output, and this is the FFT of our output after passing through differentiator circuit. In our original FFT, we are getting two peaks, F1 minus F2, which is 5 kHz, and F1 plus F2, which is 15 kHz. And this is because we are multiplying two sinusoids of 5 kHz and 10 kHz frequencies. After passing through differentiator circuit, this is a high pass filter. It retains the dominant frequency and filters out the lower frequency. So we can see only one bigger peak, that is F1 plus F2, 15 kHz, and it filters out or attenuates the lower frequency. And you can see this is our output.